Permutations, ladies and gentlemen. Let me zoom it in just a wee bit more. And make that the full screen. All right, permutations. Permutations are a way to count a certain type of event. And this event is when you want to arrange things in a certain order, and when that order has to fit some specific criteria. And this permutation, the way that I always kind of explain it is I explain it by examples, and then we kind of figure out exactly what's going on. Here's an example. You go with 5 friends to a movie, and none of you have tickets, so each of you has to buy a ticket. A permutation is going to count the numbers of ways that your group can actually buy the tickets. Like, so for example, if you have 5 friends buying movie tickets, it can go, if you number your friends 1, 2, 3, 4, 5, it could go 1, 2, 3, 4, 5. It could go 1, 3, 2, 5, 4. That's an order that it can go in, etc. I mean, there's a lot of different ways you can do this. Now, the counting principle says, how many choices of friends do you have for the first person in line? If there's 5 people in line, how many choices do you have? 5. Now, if that person's first in line, can that person go second, and then third, then fourth, or is that person done? They're done. And that's the big thing about a permutation, is that person's done at that point. So how many people do we have left here? 4. And then we have 3, and then 2, and then 1. And the counting principle tells us, what can we do with this? We multiply it. And if you have a number that, like 5, 4, 3, 2, 1, and you multiply them, I'll just go ahead and define this. Have you ever seen that? This exclamation point is something called a factorial. Yes. If you have like 4 factorial, it's 4 times 3 times 2 times 1. If you have 10 factorial, it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Because it's still part of the string. Even though it's trivial, it's still part of the string. You can't just throw it out just because you multiply it and it's 1. Now, the thing is about a permutation is this idea can extend, because even though we had here where we had 5 friends, let's say, and I always like to use this one too, you have a race. You have 8 swimmers. I use swimmers because I coach swimming. 8 swimmers race to win a gold, silver, or bronze medal. Now, how many places are there? Alright, so there are 3 places. So if we do this, there's 3 places. How many swimmers could possibly win the race? One person can win the race, but of the 8, any of them could. So we'd say that there are 8 choices to win the first race, or to win the gold medal. Can the person win the gold and the silver at the same time? No. If you win the gold, you win the gold. So how many people are left to win? That's gold.
8, 7, 6, 5.
And then silver would be 7 because that person already finished the race. Now there's 7 people swimming. Now the person who finishes second finishes. There's still 6 people swimming. So how many people can win the bronze? 6. And so all we would do is 8 times 7 times 6. And this ends up being a calculator problem, unless you could do this in your head. Where we could go 8 times 7 times 6 and enter that, and we get 336. So there are 336 possible outcomes to this race, where anyone from whoever's in lane 1 to 8 could possibly win this race. Now, this is a permutation. And by definition, it's a permutation. Using your calculator, you can actually skip this part of it where you draw the 8, the 7, and the 6, because sometimes it gets a little bit complicated with bigger numbers and bigger things like that. If you know 2 things, N, how many swimmers? How many swimmers are in the race? 8. Now R is equal to the number of places to finish. How many places are there? There are 3 places, and that refers to gold, silver, and bronze. Now there's something called NPR. And it's not an equal sign. It will be NPR, comma, and then we're going to use N, comma, R. So it would be NPR, parentheses, the number of swimmers, which is 8, and the number of places that they can finish is 3. So our calculators can do this for us. And anytime that you have an order that you can put things in, like putting books in order or putting anything in a specific order, that's when you're going to want to use this idea of a permutation. So it's always at the bottom of the page. I say anything in the Inspire can be found in the menu section. This is a different version than you have, different version of the calculator than you have. But we both have probability. And my probability is 5, so I'm going to go there. And it says permutations. So I'm going to go to permutations, and it'll come up with NPR on the screen. Now when it comes up with NPR on the screen, then all we have to do is type in 8, 3. 8, 3. And the comma is all the way down near the O key on the keyboard. You hit enter and you get your 336. Now if they changed it to 4 places, you can even type it in, NPR, open parentheses. Now if they have a gold, silver, bronze, and honorable mention or something like that for 4th place, 8, 4. It'd be 4 places that they can go in. And then all of a sudden you have a lot more different ways that the race can finish.
Well, you just have to do that.
That's all you have to do, and it'll take care of the 8 times 7 times 6 times 5. That's exactly, the calculator will do it very quickly for you. Now, just like before, when I said you had 5 friends and you stood in line, we figured out it was 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1 is 120. So if I wanted NPR, you have 5 friends and 5 places in line. menu, go to probability, go to permutations, 5, comma 5, hit enter, and you get 120. You could have just typed in NPR and then open the parentheses. Make sure you open up the parentheses. So permutations are always about putting things in order. And once something gets put into a specific slot or a specific place or location, it's done, it's used up, you can't use it again. That's the whole idea of we can't replace it back into the group. So that's what we're going to get with permutations. So any questions on what permutations are? Alright, now combinations, this works a little bit differently because combinations says, alright, we have a bunch of people, like for example, in this class we have about 25 people, and let's say I want a group of 4. I don't care who's in the group, I just want to know how many groups of 4 I can make. Well, basically what I want to know is how many different groups of 4 I can make if I'm just choosing 4 of you. So, example, there's 25 students in class. Alright, so you have 25 students in class. You want a group of 4. And the question would be how many different groups of 4 can you make? Now the math behind this is a little bit different, but when you're talking about group size and they say I want a group of a certain size, use NCR. Or it'd be NR. That's where the N and the R come from. The N is the items you choose from. R is equal to group size. So if I have 25 students and I want a group of size 4, I would type into the calculator this, 25, 4. Because that says I need to get a group of 4 out of 25. And this is only getting one group. So menu, you'd go to probability, go down to combinations, and then you get your NCR, which is different than the NPR. The NPR is putting people into different specific places, and NCR is just making a group. And so we go 25, comma 4, and it says I could make 12,650 different groups of 4. So if I just picked one group of 4, not caring who gets picked, when they get picked, or anything like that, I can make over 12,000 different groups. Just from a group of 25 kids, I can make one different group. Another example, even though the Pistons are out of it, another example that I like to use is a basketball roster has, say, 13 players. A starting lineup is a group of 5 players. If you don't care about position, if you don't care what position they play, how many different starting lineups can you make? So you're the coach, you have 13 players, and if you don't care about what positions they play, like guards, centers, forwards, if you don't care about that at all, you just want to get a group of 5 on the court, then what's my N? How many total players do I have? 13. R is my group size. The group size is 5. So I want NCR 13, comma 5. So I would type in NCR, open the parentheses, 13, comma 5. And you can make 1,287 different starting lineups. I want to do one more example, and this is going to highlight the difference between the two of them. I'm going to use basically this a similar situation and then highlight the difference between the two of them. Alright, so in a class of 25, you can elect a president, vice president, secretary, and treasurer. How many ways can you do this? Now, the first thing is, you have to ask yourself, is this a permutation or combination? Is this putting one person in and then a second person in and then a third person in and a fourth person in, like if you're lining them up? Or is this like choosing a group? Yep. This is a permutation because we're getting specific. You can have a president, you can have a vice president, you can have a secretary, and you can have a treasurer. Yep, that's your permutation. Now we could do 25 times 24 times 23 times 22 because 25 people can be president. Now, can you be president and vice president at the same time? No. So after 25, the president gets thrown out. We only got 24 to choose from. Then can you be VP and be the secretary of the treasurer? No. So you kick those guys out. So you can either do this, multiply it like this, or you can do NPR. How many people are there that we can choose from? 25. And there's 4 positions open. So menu 5, 2, 25, comma 4. That's 303, 600. So that would be if we just used NPR to figure this out. Now, another way of looking at this is in a class of 25, you elect a group of 4 to serve in the student senate? How many different groups can you choose? Now again, you got to ask yourself, is this a permutation or a combination? You're right, it's a combination. The first situation was we're actually picking the president, vice president, secretary, and treasurer. This situation, we're just picking a group of 4. We don't know if one's going to be a president or a vice president or a secretary or a treasurer or whatever, because we don't care. We just want a group of 4 that's going to go serve in the Senate. So what's my N value here? 25. What's my R value? How big is the group? 4. And I'll put that as your group size. So this would be NCR 25, 4. Alright, so I did NCR 25, 4. I hit enter and I get my 12,650. So I can make, or we can, if we did it totally by random, there'd be 12,650 different combinations of 4 people that would serve in the Senate. We don't care who gets picked first, second, third, fourth. It doesn't matter as long as they're in the group. And these 2 situations are really a good way of highlighting the difference between permutations and combinations. If you are picking specific spots where people are going to be in, like president, vice president, winning a gold, winning a bronze, going in first place, second place, in a line, that type of way, if you can put something and then eliminate it from it, usually it's a permutation. Combinations are you're looking for a group, and that's usually your biggest key for the difference of them. Is, all right, I'm just making a group. If I make the group the proper way, then everything works out the way that it should.